Hello, everyone. This is Elisa Baum. I am GridGain Systems Director of Product Marketing. We'll begin in just a moment, but first I need to conduct a bit of housekeeping. Could you please raise your hand using the hand icon located in the GoToWebinar control panel to let me know if you can hear me? So let's see here, audience. I see hands. Fantastic. Next, during this webinar, you will be on mute, but should you have any questions during the discussion, enter them in the questions field within the control panel. And at the end of the webinar, we'll take time to answer as many questions as possible. And in addition, I'll make sure that you receive a link to the recording and slides within 48 hours. Now, a brief introduction to today's speaker. Well, today's webinar is called Getting Started with Apache Ignite as a Distributed Database, and it's being presented by lead architect Valentin, or Val, Kulichenko at GridGain Systems. And for those of you that are not familiar with GridGain Systems, we are the company that originally contributed the code to the Apache Ignite project and are the leading contributor of the project today. We also provide the only commercially supported release of Ignite, along with security, deployment, monitoring, and management capabilities, global support and services. And for those of you who don't know Val or haven't worked with him, he's not only GridGain Systems lead architect, but also the #1 contributor to the user forum and Stack Overflow sites. Not only does he work on product, but he's seen just about everything that can trip people up, so be sure to ask him really hard questions. Val is here today, and he's going to share his insights into using Apache Ignite as a distributed database for high-volume, hybrid, transactional, and analytical apps, otherwise known as HAP. And with that said, happy Valentine's Day. Val, you have the floor.
All right, thanks, Elisa. Thanks for a great introduction, and hello everyone. So my name is Val. I'm indeed the lead architect at GridGain Systems and one of the committers of Apache Ignite project. And today I will be talking about the Apache Ignite, and in particular about how Apache Ignite can be used in the distributed database use cases. So basically, I will cover the following topics. So I will first talk about what capabilities are available when we are talking about Ignite as a distributed database. So how can you connect to the database? How can you use it? And so on and so forth. Then I will also do a brief explanation about how it works under the hood and describe the under the hood architecture of Ignite and how it all works. And then we will dive into the configuration part of that. So that would be more like a getting started guide. So I will give some example configurations of how you would configure the distributed database, the Apache Ignite distributed database, and how you would use it. And then I will also show a demo just to demonstrate all these capabilities and configurations. So let's get started. And for those who are not familiar with Apache Ignite, here is like a high-level architectural diagram, which basically shows all the main components of the product. So this is so Apache Ignite is a distributed and scalable caching and database platform. And in the heart of it is a memory-centric storage. So we have this memory-centric storage, which basically is a distributed data storage layer, which is ACID and fully SQL compliant, and which provides different APIs to interact with the data that is stored in that storage. APIs include SQL API, first of all. That's probably one of the most popular and mostly used APIs we have. NC99 compliant SQL with DDDML and DDL support. I will be covering that in more detail in a bit. We also have key value APIs, so you can use Ignite as a data grid or as a caching layer or as a NoSQL database. So that's also available. And you can even mix and match them. So you can have a single data set and you can use both SQL APIs and key value APIs to access the same data. So that's pretty convenient in some use cases. We also have full transactional support, ACID transactions, ACID distributed transactions, both pessimistic and optimistic, and with different isolation levels as well. We also provide the compute grid API, which basically allows you to run any arbitrary computations on the cluster. It's a very feature-rich component with a lot of different load balancing and failover capabilities. There is also, you can also deploy your own services on the same cluster, which is basically that basically allows you to create kind of a microservices architecture and deploy different functional pieces on the cluster and then remotely invoke them from the clients. We also have streaming APIs as well as machine learning libraries on top of Ignite as well. So and at the bottom we also have the persistence layer, which basically can, so you have different options there. So first of all, you can integrate with any third-party persistence store, like a relational database or NoSQL database like Cassandra, or maybe MongoDB. It can also be HDFS or anything else for that matter. So it's a custom integration with any possible storage. We provide some out of the box. Some of the integrations are provided out of the box. For all others, you may need to write some code, but integration would be possible with any kind of storage. And also, we since Apache Ignite 2.0, we provide our own persistence store. We call it Ignite Native Persistence Storage, which is basically a distributed disk storage, which is also ACID compliant and SQL compliant. So you don't need to write any code here, of course. It's fully provided out of the box, and it is very highly integrated with the memory storage as well. So let's move on to the distributed database part. So as you probably noticed, Ignite is many things. So you can use it as a data grid, as a compute grid, service grid, and what's not. And one of the major use cases for us is a distributed database. So like imagine you just have a data set and you want to put it somewhere, and then you want to query it, most likely using the SQL language. So for that, you have a lot of options. There are a lot of like relational databases, for example, like Oracle, Postgres, or MySQL. But they have certain limitations, of course. First of all, they're not scalable. So if you hit certain limits, if you hit data storage limits or maybe throughput limits, the only way to overcome this is to scale up. So to increase the amount of resources allocated to this particular machine that is running this database. With Ignite, you don't have this problem. With Ignite, you can just scale out by adding more nodes to the cluster. So it's a highly scalable and dynamically scalable distributed database, which stores data both in memory and on disk in case you have the persistence feature available. And which provides different APIs, SQL API, and as well as JDBC and ODBC driver on top of that. So again, like as for connectivity, you would probably, if you use Ignite as a database, you would probably like to connect using some standard APIs and standard approaches available that you would use with any other database. And the most common way is, of course, using like different drivers like JDBC driver and ODBC driver. So if you have a Java application, you will want to just create a connection, JDBC connection, and then use JDBC APIs to update and read the data. So Ignite provides both out of the box. So both JDBC and ODBC drivers are available. So as I said, you can just create a connection providing a specific Ignite URL, specifying the IP address of one of the nodes, and it will connect, and it will allow you to interact with the data using standard JDBC APIs. The same goes for ODBC, and on top of that, we have different other APIs, like we have REST API, which is basically a HTTP-based API. So we have like a Jetty container on every node running, and you can connect to that one and also execute some simple operations on that. And we also have native APIs, of course. So like if you don't want to limit yourself with SQL only, you also want to use key value APIs, for example, or maybe execute distributed computations on top of the data. You can just switch to a native Java API or .NET API or C++ API, depending on which platform you're using. And in this case, you have all the APIs that Ignite provides and all the capabilities that Ignite provides, not only SQL. So as for SQL capabilities, as I already mentioned, it's an NC 99 compliant SQL. We support DDL language as well as DML language. So as for DDL, these are the commands that are currently available. It's not a full support at the moment, but it's there's a lot of stuff in development right now, and you can go to Apache Ignite developers list to have all the announcements on that. But that's what we have available right now. So we have create drop table command available, so you can create new schemas from scratch just using SQL. There's also create drop index and alter table command, so you can modify the existing schemas as well as remove them completely with all the data if that's needed. So this syntax is pretty much standard, the same as you would see in any other database. Of course, there are some specifics due to the fact that it's a distributed system, so you will want to configure different specific parameters like number of backups, for example, number of backup copies for the table rows, or affinity key for the collocation and stuff like that. So for this, we have this custom with close in the create table command and in other commands as well, which allows to provide these specific parameters. But other than that, that's absolutely standard syntax. So there is nothing new for you and nothing specific for Ignite. So data manipulation language is also supported. So you have all the possible SQL commands available, which are in NC 99 specification. So you can run any kind of select queries with joins, with aggregations, with filtering, ordering, group bys, and whatnot. We also support subqueries. And you also can update data using SQL as well. So insert, update, delete commands are also available. There is also merge command, which is supported as far as I remember. It's not mentioned here. It's kind of an absurd command that allows you to insert if it does not exist yet, and update if it already exists. So so the bottom line here is basically you have all the capabilities to work with Ignite as with a distributed database. So you can just take a JDBC driver or a ODBC driver, create a standard connection, and use the standard JDBC or ODBC APIs to update it, to create the schema, to update the data, and to read the data as well. So I would also like to cover joins a little bit in more detail, because joins is actually it's a very tricky topic in distributed systems. And the main reason for that is that when you have two tables, imagine this simple schema where we have a country table and a city table, and the city table has a country code which is a reference to the country table. Right, so basically to properly do the join, we need to make sure that all the cities that cover a particular country reside in the same physical location where this country entry resides as well, right? So in particular, if we have a Canada entry on the first node, we need to have all the Canadian cities on that first node. And the same goes for India. If India resides on the second node, then we need all the cities to be next to India as well. because otherwise, if we do the join, they will not match to each other, right? So if they're on different nodes. So in Ignite, it's achieved. There are different ways to achieve that. It's called affinity collocation. I will not go into all the details about how to do that, but basically there are mechanisms just to specify the affinity key, which will be used to achieve this kind of collocation. In this case, that would be the country code. And you can do this when you create the schema. So when you create the city table, you will specify that the country code is affinity key for this table, and it will be collocated with the country. And we will get the distribution similar to what we have shown here on the slide. So all the Canadian cities are next to Canada, all the Indian cities are next to India. And then when we do the query like shown here in the example, we'll just send it to every node in topology, execute it locally there, and then get the result and reduce the results on the client. So that's the most effective way to do that, and you should always consider this. You should always think about collocation when you switch from a non-distributed database to a distributed database. That's usually like a very it's kind of a pain point when our users do this kind of migration, because I mean they just switch from a Oracle, for example, to Ignite without doing any changes to the data schema and without considering the collocation properly, and performance goes down instead of going up. So that's what you should always keep in mind. At the same time, we actually support non-collocated joins as well. So if you do not do the collocation, it will actually work. It will work properly. It will, meaning that it will return correct results, consistent results. However, performance-wise, that's not a good idea to do that, because if you do not collocate and you have this, your data set looks like shown here, like you have some Canadian cities on the node, on the second node, while the Canada itself is on the first node. When we execute this kind of query, we will have to do the data movement. So Ignite will basically automatically reshuffle the data and achieve the collocation, and only then run the join. So again, this will work, but this will work much slower than in collocated scenario. So this is usually used like a last resort, you know, when you cannot predict all the possible joins in the system or something like that. So for rare queries where you do not really care about the latency, that's okay to use it, but I would encourage not to overuse it. So always collocate as much as possible. All right, a little bit about the architecture, about the underlying architecture. So the memory-centric storage I was talking about earlier is basically based on the durable memory architecture, which allows you to store and process the data and indexes both in memory and on disk, which basically allows you to achieve both in-memory performance and durability of the disk storage at the same time. It's kind of architecturally, it's kind of similar to virtual memory architectures that you can see in operating system such as Linux, for example. The only difference is that Linux uses this for swapping, right? So if there are any memory pages that do not fit in RAM, it will just put them on disk. And once you restart, or you restart the process, or you restart the computer, all this data is lost. So it's even if it's written on disk, it's still a volatile data. Ignite uses this for durability and for persistence. So whenever you write something into one of the memory pages in Ignite, this page will be also persistent on disk right away. So disk always has all the data. And if you restart your cluster, you still have the data, right? So this brings like multiple advantages here. So first of all, the disk storage can have a superset of data. So unlike many other distributed data systems, you are not required to have everything in memory. So you can, whenever you restart the node or whenever you restart the cluster, the data that is on disk is available automatically, and it's available right away. So even if something is not available in memory, Ignite will automatically figure this out, and will fetch this particular piece of data that you need from disk back into memory for faster access. So disk can have, so again, disk can have a superset of data, right? So this is very useful in like different analytical use cases or mixed use cases where you have a big historical data set, like huge historical data set, which does not fit in memory, like petabytes of data or something like that. So it does not fit in memory. And you don't even need this in memory because the most of the data is hit very, very rarely, right? So you want this data to be somewhere available, but you don't really need this in memory. So that's where this durable memory architecture is very, very useful. And another big advantage of this architecture is instantaneous restarts. So basically, as I said, once you restart something, the data is available right away because the memory and disk layers are highly integrated with each other, so you're not even required to have the data in memory. So when you restart the cluster, you can continue using the system right away. You do not have to rehydrate your caches. You do not have to preload the data back into memory to work with it. So once you restarted the cluster, you can work right away. There is the downtime is minimal in this case. Like restarting the cluster usually takes seconds or minutes at the very least, while the data reloading can take hours sometimes. And on memory level, we use the off-heap storage, which is outside of the JVM. And this basically means that garbage collection is not aware of that, and this way we avoid noticeable GC pauses and achieve very predictable memory consumption. And this actually allows you to have rather big memory spaces there without being afraid of long GC pauses and downtime because of that. So persistence itself, so once you enable persistence, so what basically happens is that every node will have a bunch of files storing this data. And there are two main parts there. So the first one is the write-ahead log, and the second one is the actual data files, which are like partition files. So for each partition, for each Ignite partition, you will have a separate file there. So why we have this is basically the main reason for having this split into these two parts is that is performance, of course. So when you update something, we have to persist to disk, otherwise we cannot achieve consistency, and we need to do this synchronously. And what we do is we actually only update the write-ahead log. The write-ahead log is an append-only file, so it's pretty fast to update the append, like to just append the file, right? The throughput of writing to append-only file is pretty high if we compare it to throughput of random access writing to partition files in our case, right? So if we just write directly into partition file, that would mean that we have to choose the right file first, then we have to go into the middle of the file and change the content there and stuff like that. So that would be really, really slow, and the performance of update will really suffer because of that. With write-ahead log, that's not the case. Of course, it's slower than memory-only update, but it's much, much faster than random access, and performance doesn't go down that drastically because of that. So that's the only thing that happens synchronously with the update after we updated the memory is the write-ahead log update. So we just add a new line at the end of this write-ahead log. And then we have, and right away, and right after that, we can acknowledge the client that operation is successful. And then we have a checkpointing process, which is a background process, which kicks in every now and then, and which basically takes all the pages from memory that were not persisted yet and writes them into these partition files. So this is a background process. It does not really affect the performance of the latency of the individual updates. and having all the partition files and the write-ahead log since last checkpointing, we can always restore the full state. So this way we basically achieve the best possible performance, and we still have full consistency of the data. So we never lose any updates. All right, so let's enough for the theory, and let's go through some more practical stuff and see some configuration examples and see how you would configure Ignite data storage. Let's start with a simplest example possible. So first of all, there is a data storage configuration property on the Ignite configuration and the data storage configuration bin, which basically encapsulates everything there. And the data storage can consist of multiple data regions, and each data region can have multiple caches or multiple tables. Right. So in this most basic example, we only have one single data region. That's probably most common configuration, of course, right? We just have one single data region configuration, which is the default one. Default data region is the data region that is used for all the caches that are not explicitly assigned to any other data region. Right, so if you just create a cache without specifying which data region it should be stored in, it will go into the default data region, which is configured here through this default data region configuration property. Data region configuration has like multiple parameters there, but probably the most important here is the maximum size, which basically defines how much memory you want to allocate for this region. So here, in this example, we have a data region with 4 GB of memory allocated. So regardless of how many caches we have in this region, it will never use more than 4 GB of memory. And the default behavior is just to throw an out of memory exception if you try to exceed this limit. So if you reach the limit and you try to insert something else, this update that tried to do this will just fail, and you will get an exception on the client saying that there is not enough memory. So you need to remove something from the memory first, from the database first, and then you can insert your new data. So as I mentioned, you can have multiple data regions as well. So you're not limited to a single data region. You can have many of them, as many as you'd like. There are different cases when you might do this. The most trivial example is that when you have different unrelated data sets and you want to have different limits for them. So here in this particular example, we have 2 data regions. The first data region is only 4 GB of memory, and the second data region is 128 GB of memory, right? And when you create a cache, you will specify which data region it belongs to. Like here, we have a small cache that belongs to the smaller data set and a couple of larger caches which belong to the larger data region. And what it means is that the limits here are applied on the per data region level. So when you put something and you insert something into your small cache, and again, you reach the 4 GB limit, you will get an out of memory exception, even if the larger data region, is empty, right? And larger caches are empty at the moment. You cannot use the memory that is allocated for the large data region by the small cache because it's assigned to a different data region. All right, so far we had only went through the examples of in-memory only scenarios, right? So we didn't have persistence enabled, first of all, and also, as I mentioned, we were getting like out of memory exception in case we exceeded the limit. So what if you want to avoid this? What if you want to automate this process of removing the stale data and so that you can insert your new data at any moment of time? So for this, you can use the data eviction that is also supported. by the Ignite data storage. So for any data region, you can not only specify the memory limit, but you can also specify the eviction policy, basically, and the mechanism how the data is evicted if you go beyond this limit. So there are two main parameters here. So the first one is eviction threshold. And that's this threshold when the eviction starts. So once you leave, and it's 90% by default. So this basically means that when you reach the 90% of the limit of this 4 gigabytes here, the data will be, some of the data will be evicted. Some of the existing data will be evicted, and memory will free up for the new data that you are going to add into the storage. So the page eviction mode property basically enables evictions and specifies which algorithm you want to use. So there are 3 modes available at the moment. The first one is disabled. That's pretty obvious. It just disables eviction for this data region, and that's the default one. So that's providing the page eviction mode disabled is pretty much the same as not providing this property at all, because that's the default value. By default, you will get an out of memory exception. But if you provide random LRU or random to LRU, eviction will be enabled. So random LRU and random to LRU are two a little bit different algorithms that are available out of the box right now. So let me talk a little bit about how they work. So first of all, random LRU. So basically what we do there, what it does is it tracks the last timestamp, last access timestamp for each page that is currently stored in the data region. And when we need to evict one of the pages, it picks 5 random pages out of all pages we have. And for those 5 pages, it picks the one that was not used for the longest period of time, or in other words, with the minimum value for this last access timestamp. And that would be the page that is evicted. So it is the LRU policy, but at the same time, we do not check all the pages every time we want to evict one, because that would be very resource consuming. So we first do this random step to pick 5 pages out of all we have, and then we apply the LRU algorithm. So, I mean, obviously it's possible that you will have a page that that was not used for even longer period of time than the one that was evicted. But usually this approach actually gives like a very good trade-off between, you know, between the speed of this eviction and between the resources required to detect the oldest page, and, you know, the actual effectiveness, meaning that the page that will be evicted usually will be pretty old anyway, regardless of this random step. So we also have this random to LRU algorithm, which is very, very similar. The only difference is that instead of having only one timestamp, the last access timestamp, for each page, we track 2 last access timestamps. So the latest one and the previous latest one timestamp for each and every page in the storage. And when we evict something, we again pick 5 random pages out of all pages we have, and we use the previous latest timestamp, so the minimum value that we have there. So what it does basically is it allows you to avoid a situation when a page is hit only once after a very long period of time, like maybe by accident or just occasionally, and you still want this page to be evicted. But with basic random LRU algorithm, it will not be evicted for a long time because the latest access timestamp is very, very recent. So it will be stay in memory for a long time, even regardless of the fact that it's not needed anymore. So it was just accessed once and it's not needed anymore. So random to LRU fixes this issue, and because the latest timestamp will be very recent, but the second one that we actually use to choose the page is not recent, so it's a long time ago. So we will still evict this page regardless of the fact that we just touched it. So in most cases, random LRU works perfectly fine. But if you have this particular situation as I just described, and you anticipate to have this situation, then you might consider switching to the random 2 LRU algorithm. So, and finally, you can also enable persistence. So first of all, note that persistence and evictions, they are kind of two different algorithms. So when you enable persistence, you don't have evictions anymore. And the configuration properties I just mentioned on the previous slide, they do not have any effect. Because persistence basically, first of all, the data is never evicted when you use persistence, right? Because data is never removed from the cache because you hit some memory limits. The data is always available. If not in memory, then on disk. And it just basically uses its own internal page replacement mechanism. So if you have all the 4 gigabytes of the data region full in memory and you need something from disk which is not available in memory, it will basically just replace one of the pages in memory with the page that you currently need. Sorry. So to enable persistence, the only thing you need to do is to set the persistence enabled property to true on the data region. And notice that that's on the data region configuration, which basically means that you can have data regions with persistence and data regions without persistence. So if you have a data set for which durability is not important, you can put it in one data region without persistence enabled, and another data set which needs to be durable and which needs to be always consistent regardless of any crashes, you can put it in another data region with persistence enabled. And in addition to that, data storage configuration bin have multiple properties that configure how persistence behaves. You can configure like all the paths for the files, locations of the files. You can configure the checkpoint frequency, for example. Remember the checkpointing mechanism, checkpointing algorithm that I described earlier, which is a background process and which happens periodically. So here you can configure the frequency of this process. How often does it happen? One of the most important properties here, especially for performance, is the write-ahead log mode, which has 4 modes. So the first one is the default mode, and it's not surprisingly the default one, and it's actually the full sync mode. This basically means that every time we write something into Ignite, you insert a new row into a table or you put a new entry into cache, we update the memory and then we update the write-ahead log, and we also explicitly call the fsync on the file system, which basically means that we also flush the operating system buffers in this case every time we write something. And therefore we have full guarantee that whenever we wrote something, so when the client gets an acknowledgement that the operation was successful, the update operation was successful, that means that it's already on disk in the write-ahead log and on the physical disk. Then we have the log-only mode, which is, like in my experience, is most frequently used because it provides a good trade-off between strong consistency and performance. Basically what it means is that in this case we do the same thing. We write into memory, then we write into the write-ahead log, and we also flush the application buffers on the file system API, but we do not flush the lower level operating system buffers. And this actually means that it's possible to lose some of the updates in case of power outage. You will never lose any updates in case of application failure, in case of process failure, in case of Ignite node just fails for some reason. The process fails because the data will be an operating system buffer, and the operating system will flush this data eventually into the physical storage. But in case of power outage, you can lose some of the entries there. But this is pretty much a rare event in most environments, because you basically need to lose the whole data center, right? The power of the whole data center to have data inconsistency, to have data loss. And even in this case, there are different mechanisms like snapshotting or data center replication, which allow you to still have the consistency in this case. So basically, log only is very, very often used from my experience. There is also the background mode. It's the least strong mode that we have there, which basically means that we still write into the write-ahead log, but we don't even flush the application buffers. In this case, the loss is possible even in case of process failure. And there is the none mode, which just disables write-ahead log altogether, which basically means that data will be written to disk only during the checkpointing, and the actual update will be in memory only. All right. Yeah. Sorry. So, and finally, just a little bit about performance. So that's obviously a very, very big topic, and I would not cover it in all the details. But this is the list of most important things you might want to consider when starting using Ignite as a database, especially with persistence enabled. So first of all, always properly configure your memory, right? So keep in mind that memory that you configure in the data region limits is used only for your data and for the indexes. There is also some memory needed for JVM heap for operating system itself. You need some safe cushion there for the operating system itself. Also, it needs, if you have persistence enabled, you need also some memory available for the operating system to hold all these file buffers. So it's basically around 20% of physical memory that you need to leave for all this stuff, and the rest can go into the data regions, into actual data regions, and to be used to store the actual data. Also, whenever it's possible, use production-ready SSDs, or in other words, basically, the faster your physical storage is, the better. We noticed the tremendous difference between SSDs and spinning hard drives, for example, in update throughput. It is also a good idea to have a separate physical disk for write-ahead log. Because in this case, the checkpointing interferes with the actual updates much less, and the effect on the when you do the checkpointing, the throughput can go down because of the heavy disk access, and each update still has to write into write-ahead log. Separating them to the physical disk drives can also improve that situation as well. And also there is some advanced data storage configuration which you also can apply to make sure that the persistent store performs better. Like you can change the page size. There's especially actual for data for disks and for physical storages that have non-standard page size. So we have 4K by default, which is the default for most of the disks, most of the SSDs or other disks. But if you have some non-standard page size on the physical level, then you might want to change it on Ignite level as well. There is also write throttling mechanism, which also can reduce the effect of checkpointing on the throughput of updates. And you can also play with the checkpointing buffer size. There are many others. That's not the full list by any means. There's the configuration page, this durable memory tuning configuration page that describes all these different parameters that you might want to look at, and as well as many others, providing much more detail. So if you have any issues with the performance, that would be the first source of information about how to improve this performance situation. All right, so now let me show you a quick demo. I will basically demonstrate you how to use the Apache Ignite as a database. So first of all, we need to configure our cluster. The configuration would be very simple. Let me make the font a bit larger. So that would be our configuration. I will show how to use it just in a second. But basically, that's the same that we just seen on the slides. Very basic configuration without any fancy stuff here. So we just have a default data region, single data region, the default one, with the 4 gigabytes of memory limit. So we provide the maximum size property here and specify 4 gigabytes as a limit. And we also enable persistence. So we are going to have all the data on disk and in memory. If we restart the cluster, we will be able to access this data as well. And I'm going to demonstrate that. So, and what I'm going to do is I'm going to upload a database. I have this database dump. That's like one of the sample databases available out there, which contains different geographical information. It has a country table with some information about different countries. It has city table with some information about cities, country language table, and all the data, which is basically just generated with the insert statements. So these DDL statements are already appended with the with clause I was talking about, which provides the required configuration for Ignite. Like we specify that it's a partitioned data set, for example. We specify that we have one backup for each row in this table. We also like specify affinity key here, for example. So we collocate the city table with the country table by the country code. And we achieve that providing the affinity key property here. Everything else is again is a standard syntax, the same as it would be with any other database. So it's a create table command. We provide the table name, and then we just provide a list of fields with their types. All right. So let's start the nodes. So we have our configuration. We have our SQL dump script. So let's go ahead and run the nodes. So I have Apache Ignite 2.3 downloaded here and installed. So I will just use the ignite.sh script, which is under the bin folder, to start a node, providing this ignite config XML file we just looked at. So this will start a node. We have one node, know that we have one server started. It shows this in the log. Let's start the second node. So nodes discover each other. So we see that we have two servers now. This one also has the same topology snapshot here. So we have two node cluster right now. So let's try to connect to it. So I will use the SQL line tool. It's one of the standard command line tools that uses the JDBC driver to connect. It's also included in Ignite itself for conveniency. So all I need to do is basically run this SQL line.sh script, which is provided in the bin folder of Apache Ignite, and provide the URL. So I just provide the localhost IP address. Before that, actually, I'm sorry about that. The cluster, when the cluster uses persistence, it's not activated by default. So if I actually try to do something right now, it will give me an exception because the cluster is not activated. So we need to activate it manually first. To do that, we have the under bin folder, we have a control sh script where I just provide the -- activate, and it will activate the cluster that is running locally next to the script itself. So it was activated, and now I can connect with the JDBC driver. So we are connected. I can show you. We can now run the script. So if I just do Ignite World Demo, Ignite World SQL. So I just provide the path. Run command is part of the SQL line tool, and I just provide the path to the SQL script. And it will create the schema, and it will insert all the data into my tables. It can take several seconds. All right, so all the data is inserted. So we can see that if I do like tables command, we have all the 3 tables here, and we can run some queries here. So for example, query like this, right? So this query will select basically most populated cities, 10 cities in the world. Countries in the world, sorry. So the China is the first one, then we have India, and so on. So standard SQL query, we can do ordering, we can do limit statements and stuff like that. Or we can do even something more complicated like this. So this query will give us average city population for USA, Russia, and China. So we have to use join here. We use the in close here to filter out the countries, and we also use the group by statement and average aggregation here. So that gives us average city population for these 3 countries. And also we can update. So for example, let's search for the Miami city here. So we have this population for the city, and we can update it. So like, for example, the population increased to 400,000. So we will just do a standard update statement here and execute it. So now if I select it again, we see that we have a new value there. So now finally, let me demonstrate that the persistence actually provides the durability. So let's stop the nodes. Let's imagine that our cluster died for some reason. So now if I try to connect, I obviously can't. It will give me an exception, a connection refused exception, because the cluster is not available. So let's restart the nodes. I start these 2 nodes again. First one is up. Second one is up as well. I need to activate the cluster again. So I run the control sh script with the activate command. The cluster will be activated. It also will actually restore any data that was not checkpointed from the write-ahead log at this point, by the way, so it sometimes can take several seconds. So we connect again, and so right away, I don't have to run the script again. We still have the tables. And if I run the same query for Miami, select query for Miami, we will see that we have our new value we updated with before. So this basically demonstrates how you can use Ignite. So we did not use anything Ignite specific. The only Ignite specific was Ignite configuration. So we created Ignite configuration, and then we started the cluster. Everything else was absolutely standard. And the way I did that is the same as you would do this with any other database. I just took the JDBC driver, I took a generic tool, I connected through the JDBC driver from the generic tool and ran standard SQL queries to create the schema, to read the data, and to update the data as well. So that's actually all I have for today, and now I will hand it over back to Elisa, and I'm ready to answer the questions if there are any.
Hi, Val. I'd like to introduce another voice, part of this discussion, and that's Rob Meyer. He is GridGain Systems Director, Senior Director of Outbound Product Management, and he'll actually be asking the questions today. So Rob, say hello and ask away.
Hi, folks. Can everybody hear me?
Yes.
I will take that as a yes. So let me ask the first question. This is a pretty interesting one, actually. This came up a few times. Can you set up persistence or set up Ignite so that you can access it both via SQL, so DDL and DML, or via an API, let's say a key value API?
Yes, you can. So basically, all the tables that I created here, for example, right, you can use them as an objects. Actually, let me show this real quick. So if we go to our schema description, you can notice that we provided the the key type and value type here. So that's actually how you would access it through the key value API. You can even create a class with this name and with these fields, and then you can just do a simple cache get, and it will successfully read this entry from the table and deserialize it into the object.
Okay, perfect. Another question was the reserve of 20% of the overhead for the OS and the JVM. Does that apply to all kinds of workloads, or there's some workloads that require more and others that require less, like heavy reads versus heavy writes?
That doesn't really depend on workload much, because I mean the workload will creates requirements for the Ignite process itself, for how much resources you allocate to Ignite process itself. This safe cushion that I'm talking about, let me put it this way. So you have the safe cushion on the operating system level. That's like a very approximate, value that you just probably need to play with. The only thing you need to keep in mind here is that if you have persistence, usually it needs to be bigger, because it implies having the operating system buffers for the write-ahead log updates and other file updates. As for heap size, for example, that would actually depend on the workload very much. It would not depend on read-write workload, but you may want to increase it if you have like a computational workload, for example. If you have some arbitrary computations that you run on the cluster, then the amount of heap memory and the amount of resources you need to run those computations would, of course, depend on the computations itself.
Okay. There was a very specific question, since you still have the screen up, about what value type is, or sorry, what I guess data type or value type, I think it is in fact value type, is in the DDL.
Yeah, that's basically, so under the hood, it's still a key value storage, right? So when you do an insert command, it is basically converted into a cache put operation under the hood. So we create a key object and we create a value object, and we store them as a key value entry in the cache, in the underlying cache. So for every table, we create the cache. First of all, you can provide the cache name here, by the way. Again, if you want to access this data using the key value API, that's the cache name you will use. And we then create the key and value objects. These are binary objects, and each binary object has a type name, right? And having this type name, you can even deserialize it into the actual class in Java or in .NET, C++.
Okay. There was a question towards the beginning, the very beginning, whether this is a shared nothing architecture like Cassandra, and how it compares to something like VoltDB or MemSQL.
Yes, it is. So we basically, that's a share nothing architecture. So we don't have master nodes like MemSQL does, for example. Frankly speaking, not sure about VoltDB and how it works. But our
that's more scale up.
Yeah, in our architecture, all the nodes are equal. It's a share nothing architecture. Yep.
Okay. I don't want to put you on the spot here. Do you consider yourself Kubernetes expert?
Not really.
Okay. There was a question on Kubernetes here. I'm going to refer you back to an August webinar that was explicitly about Kubernetes. If you're interested, it was done by Danny, one of our technical experts in the field. We can always send that out as a follow-up, and I'm sure there's another one. There's actually a meetup tomorrow in the San Francisco on specifically that topic, so you can always go to GridGain events and see what local meetup is happening. But Danny usually goes around and talks about Kubernetes. So I think that was all the questions.
Awesome. Thank you, Rob, for interesting questions.
Thank you, Val, and happy Valentine's Day.
Thanks everyone for coming.
Thank you, everyone. And guys, thank you so much for your support. And Val, wonderful presentation as always. Hope to see everyone on a future webinar. Our next webinar is February 20th, and it's called Redis Replaced. So if you're interested about Apache Ignite versus Redis, that's something to look at. And also we have one on March 28th, which compares Apache Ignite and Cassandra. So 2 exciting topics coming up, with much more being added in the near future. Check out gridgain.com.
Yeah.
And with that said, thank you, everyone, and have a great morning, afternoon, or night.
Thank you. And we'll flip to the last slide. Val, maybe you can flip to the last slide and give them a link to resources.
All right. Here it is.
Perfect. Yeah, if you have any other questions, there are all kinds of links here about other webinars and events and white papers under GridGain under the resources page. There's an in-memory computing summit where experts talk. Local events is under the events page at GridGain, and there's some great customer stories as well. Ignite, if you're interested in finding Val, you can usually find him on the Apache Ignite user forum or Stack Overflow. For things like figuring out how much utilization you actually are having in your Ignite cluster, GridGain actually offers a free web console that gives you some monitoring and other capabilities. And if you're not using Ignite yet, there's a Getting Started doc that you can go to that tells you how to download it and get up and running. So with that, thank you very much, and we'll hopefully see you soon.
Take care, everyone.